In these work, we exploit sensors on mobile phones to improve wide area localization for augmented reality. The first part of our approach is an offline data generation step. A large number of images is acquired, serving as a base for reconstructing the environment, using structure from motion. For each 3D feature, a descriptor is calculated by considering gravity. Additionally, a normal vector is estimated reflecting the patch orientation in 3D space. Considering the normal vector, all features are divided into slightly overlapping bins, based on their orientation with respect to north. Finally, we store the orientation-aware bin feature blocks for the entire reconstruction into a common feature database. The second part of our approach is the online localization, running on the device in real time. Providing a reasonably accurate GPS estimate, the bag of features of the actual environment block are fetched from the feature database. We generate a panorama on the fly from the live video, considering the sensors of the device to align it to north in gravity. Then, we extract features from the panorama and match them against the features collected in the corresponding orientation bin. The established correspondences are used to estimate a global pose, which is combined with the local orientation estimate of the panorama. The obtained dynamic 6-degree freedom pose is used in our augmented reality applications. We evaluated our approach against an approach that does not consider sensor information. The usage of sensors increases robustness in terms of the number of inliers. On average, the number of inliers can be increased by about 50%. A direct comparison reveals a considerable improvement in localization performance. Since a small field of view violates the wide baseline requirement of the 3-point pose algorithm, a bigger improvement is gained for a looser distance threshold. It is important to stress the proportionality between the field of view and the time to localize. Pushing the performance curve towards the upper left corner means that also the required time to localize is decreased significantly. This becomes clearly noticeable in the following videos. Using sensors, an average speedup of 1.71 is achieved, reducing the required time to localize considerably. While localization takes around 14.2 seconds without sensors, using sensors the required time to localize is reduced to 8.3 seconds. We implemented our approach on Apple iOS, testing it using an iPad 2 and an iPhone 4S. The video was directly recorded on the iPhone 4S, running an augmented reality application. Due to the highly accurate pose estimate, the unidentified flying object and the dwarf are both accurately occluded by the building facades. Summarizingly, our new approach using sensors greatly improves the application quality,